happy Friday. So today is October 21 and we will finish 4.6 exponential and logarithmic equations, right? Uh, so this week we don't have any quiz, but please work on your homework, okay? If you have questions, ask me. Okay. You can either email me your questions or you can post the questions here. Then we can go over together. Okay, everybody? Mm-hmm. All right. Okay, so last time we did some example about equations involving exponential expressions, right? We first isolate the exponential term, and then because we know log and exponential function, they are inverse function, right? So in order to get rid of the e, we apply natural log on both sides, and then we can solve for x. By the way, make sure you have your calculator. So, yeah, exam 1, if you don't have your calculator, that's fine. But exam 2, you need to have your calculator because for some of the application problems, you need to give the exact answer and also the decimals answer. So, okay, calculator. DIXS multi view like this one. Yeah. So I would recommend to buy this calculator. Yes. So it's about like $15. You can buy this tag. The good thing is this calculator is multi-line. So instead of just one line, it has like multiple line, and so you can enter everything in one line, and then you get the answer. And it also has the statistics. So in the future, if you want to do statistics, it can also help you to do that. So do you all have a scientific calculator? Yes. Mm-hmm. Okay. And make sure you have it on the exam. Okay, and then yeah, last time we also did example 2, right? Here we have two exponential terms. Last example, we only have one exponential term, but now we have two exponential terms. It's okay. You can apply natural log on both sides, and because of the properties of natural log, we can break the exponent down in front. And common mistake. Don't forget the parentheses. This is very, very important. And then you can distribute, and then we move the terms with x to the left-hand side. So the terms are separated by plus or minus. So this is one term, this is another term, this is another term, and this term has x. We want to keep it on the left-hand side. And this term has x. We want to move to the left-hand side. By moving, we mean subtract. Right, everybody? And here, this term does not have x. So we keep it on the right-hand side. So after you do that, all the terms of your left-hand side should have the common factor x. So we can factor out the x, and then x will be your right-hand side divided by this factor. Okay, so this is the exact answer, and then you need your calculator so you put parentheses ln3 parentheses divided by parentheses ln2, and then you don't forget, usually you press the ln button, there is a left parentheses. So after you enter the 2, enter the right parentheses to close that, and minus ln3 parentheses. Okay, so I hope everybody can practice using your calculator. Because sometimes if you miss some parentheses, then you won't get the correct answer. Okay, everybody? So please practice that. Okay, and then we continue. Today we continue to look at example 3. We want to find the exact solution and approximate to the nearest thousand. Okay, let's see. Alright, so here, this one. Well, all the terms are on one side. That's nice. And can you see some common factor? What's the common factor? X, right? What else? E to the x is a common factor, right? So we factor out a common factor. Okay? If you see the term has common factor, factor goes out. What's left? Yeah, 3 plus x equal to 0. Right, everybody? Oh, this is perfect. If you have a bunch of products of bunch of factors equal to 0, that means each factor equals to 0, right? So, okay, if a times b equals to 0, that means a is 0 or b is 0. Okay? And be careful, this is only true if the right hand side is 0. If you get a times b is 1, it doesn't mean a is 1 or b is 1. Because example, 2 times 1 half is 1. So 2 is not 1, 1 half is not 1. So this is only true for the 0, when the right hand side is 0. Okay. So therefore, you have a product of different factors equal to 0. That means set each factor equal to 0. So look at this factor, x. We set x equal to 0, right? Next factor, e to the x, we set equal to 0. And then the third factor, 3 plus x, we set it equal to 0. Right, everybody? So x equal to 0 is good, it's 0. E to the x equal to 0. What is the graph of e to the x? What's the graph of e to the x? Like that, right? Okay, math move. Raise your hand again. Line. Parabola. Cubic function, right? Square roots, cube roots, and absolute value, right? Exponential function, like that. Log, like that. Right? Log is, so keep in mind, exponential function is increasing, goes like that, right? And the log, so this is e to the x, log looks like that, ln of x. Right, everybody? Okay, do you see the exponential function? What's the domain? Minus infinity to infinity. What's the range? 0 to infinity, not including 0. So can e to the x be 0? No. That's why impossible. Because e to the x is always positive. Right, everybody? And how about this one? We subtract 3 on both sides. And then we get x equals negative 3. And we put or, okay? So therefore, our answer, x is 0 or x equals negative 3. So this is the answer. So far, so good, everybody? Yeah. So we move all the terms to the left hand side. And you see common factors. Oh. Okay, attendance. I realize some of you were not here, but somebody signed the name there. So from now on, I will also take pictures. Okay, so please make sure you don't help your friends to sign the attendance. Okay, so I take pictures. Alright. What? Okay, so cheers. Okay, by the way, I promise that I will delete your picture after the semester. Okay, I realized, yeah, one day I only have like 20 students, but I have 25 signature on the sheet. So okay. All right, let's continue. Okay. All right. Okay. Sometimes exponentials can appear with hidden quadratic equations. Okay, so example 4. Find the exact solution and approximate to the nearest. Okay, let's see. E to the 2x. Oh, do you see e to the 2x is like e to the x squared? Mm-hmm. So this is like e to the x squared minus e to the x and minus 6 equal to 0. Wow, this is like a hidden quadratic. What does that mean? Because you see, this term is the constant term, and this term is e to the x. But this guy is this guy squared, right, everybody? So now let's make a substitution. So we substitute let u to be e to the x. Okay, we substitute. Let u be e to the x. Oh, do you see? E to the x is u. Now this guy is u squared. And this is u, right? And minus 6 stays here. Oh, this is a quadratic equation, isn't it, everybody? Mm-hmm. Can we solve quadratic equation? Yes. We can either factor it or use the quadratic formula, right? Let's factor it. Okay, and so u and u. How can we factor it? Yeah, very good. Plus 2 minus 3. Awesome. So we got u plus 2 is 0, or u minus 3 equals 0. So far, so good, everybody? Okay, solve for u. What is u? -2 or 3? Okay, are we done? No, we need to find x, right? What's u? E to the x. Can e to the x be -2? No, because it's always positive, right? Uh-huh. And then e to the x. Can e to the x be 3? Yeah. How do we get rid of the e? Apply natural log on both sides. Thank you. So we got ln e to the x equals ln of 3. Right, everybody? Okay, and ln and e cancel. We get x equals ln of 3. Okay, so this is the solution, right? And the problem says find the exact solution and also approximate to the nearest thousands. So put this in your calculator. What do you get? Thank you. Right, everybody? If the next digit is greater or equal to 5, we round up. If the next digit is less than 5, so less than or equal to 4, we round off. Yes, everybody? Mm-hmm. Awesome. Yeah, so this is hidden quadratic. So if you see some term, it has like 3 terms, and this is the square of that, then you think about the hidden quadratic, and then you let u be that term. Okay, everybody? Yes, awesome. Okay, so that is how we solve equations involving exponential expressions. Now, when an unknown is in a log, we can solve the equation by rewriting it in the exponential form. you need to check for the solutions. Okay. Remember our domain. We have when we have square roots, then the domain, the A, we require the things in the square root to be greater or equal to 0, right? If we have fractions, we require the denominator to be not 0, right? And then if we have ln, we require the things in the ln to be positive, right? That's why when we solve equations with square roots or rational expression or log, we need to check those things. Okay, everybody? Yeah. So yeah, let's see. Okay, this one. Well, this equation we only have one log term. Yes, only one log term. If we only have one log term, okay, so this is equation with one log term. What we do is isolate the log term. What's isolate mean? Yeah, the log term is on one side by itself. Yes. Okay. How do we do that? Subtract 4 on both sides. And then we have 3 log 2x equals what? 16 minus 4 is 12. Hmm? Oh, yeah. See, sometimes I make mistakes too. So, yeah, sure. I will answer carefully. Yes. Okay, and what do we do next? Divided by 3. Yes. Divided by 3. Then we have log 4 2x equals what? 4. Okay. And then, okay, so second step. Because we want to get rid of the log. We know log and the exponential function 4 to the x are inverse function, right? So that's why both sides apply. Usually we would say b to the x because the b could be anything. But right now our base is 4. So both sides raise to the power of 4. Okay? So that means 4 to the log 4 2x equals 4 to the 4. So both sides raised to the exponent of the 4. Is that okay, everybody? To get rid of the log, okay? Log and exponential function are inverse. So the area of that 4 log 4 is, yeah, they cancel, right? So the left hand side is 2x. And 4 to the 4. Do you know what is 4 to the 4? 100. And then? Two, 256. Oh, okay. 256. Thank you. Oh, then what is x? Yeah, 128. Thank you. Okay. Are we done? No, we gotta check. So make sure if you have like square root or fractions or ln, always need to check our solution to see if it's in the domain. Okay? Yes. So we check. Okay. So we check. Oh, you see? We have the law for 2x. X is 128. Is it okay? Is it in the domain? Yeah? See? This is positive, so it's okay. Yeah, everybody? So you check the domain. That means you don't have to check the whole thing left hand side equals the right hand side. You just need to check whether it is in the domain. So So you check when you plug in x is 128. See, 2 times 128 is positive. It's okay to be in the log. So then do that here. Okay? So this is what I mean by checking. To check whether it is in the domain. You don't have to check whether the left hand side equals the right hand side. Okay, everybody? All right. So this is what we do when, let me write down here. The first step, equation with only one log term, we can isolate it, and then apply the exponential function, and then solve for x. Okay, so you can consider 3 step, and then step 4, check answers. Okay, check our answers. So 4 steps. Okay. All right, so it's good to write down the steps when we see a new kind of problems. Then we can summarize the steps, and when we see a new problem, we can follow the steps and then do the new problem, practice the new problem. Okay, so in some cases, we need to condense the log expressions before rewriting it, the entire equation in the exponential form. Okay, so if we have 2 log terms, okay, so this is equation with more than 1 log terms. Can I do that? More than 1 log terms. Okay, then the first step is you want to combine the log terms into a single log. So combine the log terms into a single log expression. Oops. Okay, that's why what we learned in 4.5 is very important, right? Log if you have the sum of 2 logs, you can combine them, you get log of the products, right? If you have subtraction of 2 logs, you can combine them and you get log of a quotient, right, everybody? And if you see like some power in front of the log, you can move the power on top, right, everybody? Okay. So here on the left hand side, we have this guy plus this guy. How do we combine them? So this is log of what? X plus 2 times x minus 1. Yes. Right, everybody? Awesome. Right. And now you can see we only have the log term on one side. So then we can do what we did before. We isolate the log term. Okay? And see, it's already isolated. If your 1 is on your left hand side, then you move to the right. Okay, so on your left hand side is only a single log term. Okay? Now, to get rid of the log term, we apply, what's the base? 10. Okay? So apply 10. So 10 raised to the power of the log x plus 2, x minus 1 equals 10 raised to the power of 1. Yes, both sides raised to the power of the 10. Now 10 and log cancel. So we have x plus 2 times x minus 1 equals 10. Right? See? Now we have a quadratic equation. Oh, does that mean x plus 2 equals to 10 or x minus 1 equals to 10? No. All we need to do, we multiply everything out. Okay? Multiply everything out and then combine the like terms. And then either quadratic formula or differential. Okay, now let's see. All right. Okay, so yeah, so step 4, we're gonna solve the polynomial equation. Okay, so which means you want to distribute, or you can say expand, and you want to move all terms to the left hand side and factor the left hand side. You set each factor equal to 0. Okay, set each factor equal to 0 and then solve for x. This is how we solve polynomial equation, right? After that, we check our answers because this is a equation involving law expression. So we need to check our answers. Okay, so let's see. Distribute x times x squared, x times minus 1 minus x plus 2x minus 2 equals 10, right, everybody? So, oh, that's x squared. And then, oh, minus x plus 2x is plus x, right? And then what? Minus, if you move the 10 to the left, what do you get? Minus 12 equal to 0. Yes, everybody? Okay, can you factor it? X, and then? Yeah, plus 4 minus 3. By the way, if you couldn't factor it, then you use the quadratic formula. Okay? You might get irrational answers or complex answers, right? Okay, if we can factor it, then we set each factor equal to 0. Okay, set each factor equal to 0. And solve for x. Yes, so x equals to 34 or 3. Yes? Okay, now we need to check. Okay, for x equals minus 4, you want to plug in all the log terms and see if that's okay. Look at the first log term. Log x, so negative 4 plus 2. Is this okay? No, it's not okay. By the way, if you check one term is not okay, you don't need to check the others. It's not okay at all. Right, okay. So how about you check x equals to 3? The first term is log 3 plus 2. Is this okay? Yes. Second term, log 3 minus 1. Is this okay? Yeah, okay. So our solution is x equals to 3. Okay, everybody? Mm-hmm. Yes. All right. Okay, so these are the steps, and this is how we solve the problem. If you have a similar problem, you can do that. Oh, how about it's your turn? Do the next one, okay? So log 5x plus log x minus 1 equals to 2. Yes. So do this problem. See? Did one of you forget to sign in? Oh, you signed in. All right. So let's check our answers. See? Okay. Let me click this note with answers. All right. Okay. So here. Step 1. We combine the log into a single log, right? So sums, we combine the sum into products. So 5x times x minus 1 is 2. And now we can both sides raised to the power of 10 to carry out the log. Here is 10 squared. Okay, so here we have 5x times x minus 1 equals 10 squared is 100. So what I did is, because I see both sides has a factor 5, so I both sides divided by 5 to make it easier. And then after I do that, this is a polynomial equation. So you want to distribute, expand, and move all the terms to the left-hand side. So that's why x squared minus x, move the 20 to the left. So now all the terms are on the left-hand side. We can either factor or use the quadratic formula. Okay, so here we can factor it x plus 4 times x minus 5 equals to 0. So we get x plus 4 is 0 or x minus 5 equals to 0. So we have x equals to negative 4 and then x equals to 5. Right. And when we plug in negative 4, so log of 5x, so x is negative 4 plus log negative 4 minus 1 equals to 2. So in the exam, you don't have to do that. You can just put this guy comma. Okay, and we check, this is negative, so done. This is not in the domain, then you don't need to check the rest. Is that clear, everybody? Mm-hmm. And then 5, the 5, you put, log 5 times 5. That's okay. And then you can put comma, log 5 minus 1. That's okay. And then you say okay. Is that clear, everybody? You just need to check whether it is in the domain of all the log fractions. Okay. Any questions? You all understand? Yes? For this problem? Mm-hmm. Okay. Good. So if you have questions, feel free to let me know. And also your homework. If you have questions, print screen your questions and email to me. Okay. All right, example 8. So you invest 500 at an annual interest rate of 6.75%, compounded continuously. How long will it take your money to double? Okay, so how do we do that? Well, remember the compound interest formula? If we have the compoundings, okay, so we have two set of formula. One set is P times 1 plus R over N raised to the power NT. We use this formula if it's compounded like quarterly or monthly, and then N is the number of compoundings. Do you remember that? Okay. And the other formula is if we get compounded continuously, then A equals P times E to the RT. Right, everybody? So in section 4.1, we learned this. And the example we did was like, oh, okay, let's say we know the interest rate and we want to find the money in the account after 6 years. Then you plug in your principal, your rate, and in 6 years you get the amount, right? But today, we know we're gonna double the money and it's looking for the time. Do you see it's the reverse direction? Okay, what we did before, we know the time, and then we plug in and we get the amount of money, right? Today we know the amount of money doubled, okay, and we want to find the time. So this is like the reverse direction. Okay, let's see. So what's 500? 500 is the P, yes? What's 6.75%? The R, right? This is the R. And this is point what? 0.675? 0.0675. Yes. Okay. Now, so we know the P and R, we can plug in. Yeah. So we got, okay, A is P is 500, E to the R, 0.0675 T. So we plug in this formula and this is what we get. Is that okay, everybody? Okay, and then now what are we doing? We want to find how long. How long means find the time. T such that the amount at that time equals to double the amount. Double the amount means, well, your initial amount is 500. When you double it, you get what? 1,000. Yes, everybody? So we want to find the time T such that A of T, yeah, so A is a function of T, A of T equals 1,000. Is that clear, everybody? Okay, so the A is 1,000. So the A is 1,000. See, the A is 1,000. So plug it in. We want to find the T. See? Now this is an equation involving exponential expression. Okay? Yeah? How do we solve for T? It only has one term, exponential term, right? So we isolate it. How do we isolate it? Yeah, divided by 500. So divided by 500, what's your left hand side? 2. Yeah. So we divide it by 500. Left hand side we get 2. Right hand side e to the 0.0675 t. Right, everybody? Okay. What do we do next? How do we get rid of the e? Natural log on both sides. So ln2 equals ln e to the 0.075t. E and ln cancel. So 0.0675t. Aha! What is t? The ln of 2, right? Divided by 0.0675. Okay. Now you use the calculator. And please, when you do the real world problems, only use your calculator at the very last step. Okay? So don't use your calculator here at your decimal, because then your answer won't be so accurate. So keep this exact form. Do the calculator at the very last steps, then your answer will be as accurate as you want. Okay, so yeah, put this in your calculator. What do you get? Give me 3 decimal places. Thank you. And that would be years. Right, everybody? So, you start with $500. It really took you 10 years. Maybe 10 years and 4 months or 3 months, I don't know. Okay? So that your money can double. So far, so good, everybody? Okay, so this is the application problem. So yeah, now we can do the reverse direction, knowing the amount and find the time. Okay, so yeah, today we want to just focus on 4.6. So let's see. Okay. Right. Let's do number 3. Okay, please try number 3. We have 3 laws. Yeah? So what do we do? So you want to combine them. So both sides have the same law. Then you can apply the exponential function to carry out the law. Okay? The law property, we combine the sum into product, the difference into quotient, and the power you can move it on top in the exponent. This one, you can use the 2 when you have the long x. No, right. It's not 2. Maybe have long x. what you have on the right hand side. Yeah. And then your log x squared is on this side. Then you raise the power of 10. Yeah, and this is log of that. Yes, raise the power of 10. Okay, so let's check our answers. So, let's see. Okay, so we have combined the used property, the two, we can move it up there. So we got log of x squared, right? And right hand side, combine the sum into products. So we have 2 times 3x minus 4. Is that okay, everybody? So once you make sure both sides has a single log, then you can both sides raise to the power of 10. So in this case, you don't have to like move all the terms on one side and combine them. Okay? So 10 to the log x2 equals 10 to the log of 2 times 3x minus 4. Do you see 10 and log cancel? We have x squared. 10 and log cancel. We have 2 times 3x minus 4. Yeah? And, oh, okay. We distribute. What's 2 times 3? 6x. And then minus 8. Okay, this is a quadratic equation. Right? So we can move all the terms to the left-hand side. So x squared minus 6x and plus 8. Right, everybody? So that is, okay. How can we factor it? Yeah, very good. So we have x minus 2 is 0, or x minus 4 is 0. So x is 2, or x is 4. Okay, let's check. If we plug in x is 2, look at all the log. We have log x. X is 2. Is that okay? Yeah. Oh, and log 2 is always okay. It does not have x there, right? And log 3 times x is 2 minus 4. Is this okay? Yes. Okay. How about x equals to 4? So log x become log 4. Is that okay? How about log 3 times 4 minus 4. Is this okay? Yeah. Oh, both of them are okay. So both of them are solutions. Okay. All right. Yes. Let's try to do some example, because the example we are doing is sum, so we combine the sum into products. I want you to do some example to combine difference into the difference, combine difference into division. Let me see, will your practice exam has some problem like that? Let's see. Practice exam. The practice exam has subtraction. Yes. Okay. So please do this problem. Ready to raise the power. This is pretty. So you multiply both sides by the common denominator to get rid of the denominator. Anytime remember. See? Okay. We divided by that. Yeah, so we first combine the subtractions into division, right? So see, on the left hand side is the single log, so it's already isolated. And then we can carry out the log by here, log 3, base is 3. So you don't apply like 10 to the power. You apply both sides by 3 to the power. So 3 to the log 3 of that equals 3 squared. Right, everybody? Mm-hmm. So then this cancel. So 3x plus 5 and over 8x minus 1 equals 9. So this is equation involving rational expression. Clear the denominator. Both sides multiply by ax minus 1. Yeah, anybody? Mm-hmm. Both sides multiply by the common denominator. Then distribute. So 7x minus 9. Combine the x. So subtract 3x, subtract 3x You get 69x. Combine the constants. So move the 9 to the other side. You get 14. So x is 14 over 9. And then you put this into the expression. So the log 3 times that number plus 5. Yeah, it's positive. Good. And 8 times this number minus 1. And this is also positive. Good. So this is the answer. So far, so good, everybody? Yeah, if you see subtraction, we combine them, then we get division. And be careful! Yes, common mistake. This is not log 3 of 3x minus, plus 5 over log 3 of ax minus 1. Okay? Yeah, we know division and subtraction, they are different, okay? So the division must be inside the log, right? Inside the log. So that's why I say if you have a mistake book, to write down the common mistakes, and then before the exam, you can look at the mistake book and remind yourself, okay, don't make this mistake again, be careful, calm down, yes. Okay, everybody? Mm-hmm. All right. And let's see. Okay, let's continue. Oh, questions? Okay. How about this one? Solve this equation. So, hint. We write 4 to the x and 2 to the x plus 1 in terms of 2 to the x. What's 4 to the x? 2 to the x to the 2 to the x to the 2. Yes, everybody? So 4 to the x is 2 to the x squared. Yes, everybody? So 2 to the x squared. How about 2 to the x plus 1? Is 2 to the x times what? 2. Yes, everybody? And can we subtract 3 on both sides? Do you see this is a quadratic form? Yeah? So make the substitution. Make the substitution. You let u be let u be 2 to the x. Now that quadratic equation. Okay, we have 4 minutes left. Well, let's do it. So let u be what? 2 to the x. Then this is u squared, and then minus 2u minus 3 equal to 0. How can you factor it? And u plus 1. So u minus 3 is 0, or u plus 1 is 0. What's u? 3 or negative 1. Are we done? No. So u is 2 to the x. Okay, so 2 to the x equals to 3. And we apply ln on both sides, right? Yeah? Apply ln on both sides. And do you see we can move the x down in front? Yeah? So we have x ln of 2 equals ln of 3. Then what is x? Yeah, ln of 3 over ln of 2. Is that okay, everybody? Mm-hmm. All right. And how about the other one? 2 to the x equals minus 1. Is it possible? No. Exponential function is always positive. So this is impossible. Therefore, our answer is that. Okay, put this in your calculator. What's ln of 3 over ln of 2? 585. Thank you. So that's our answer. Okay. Do we need to check domain? No. Exponential function domain everywhere. Have a nice weekend. So do your homework. Ask me questions. Review your notes and recordings if you forgot something. So try your best to understand every problem on the exam, in class notes, your homework. Yeah. Bye.